Hi everyone, it's been a while since we last saw each other. In today's video, I will continue from part 1 and part 2 will focus on how to create parameters in the PCG graph. In part 1, many of you asked for a more detailed tutorial for beginners, so in the first part of this video, I will go over the basics for those who are new to PCG. In the second part, we will get hands-on with parameters. Alright, let's get started. First, I create a landscape using landscape mode in Unreal Engine, so you can follow me. I use the landscape material from Unreal Engine and assign it to the landscape. You can download it in the description below. In the Paint tab, so you will find the layer sections. Create a layer info and then paint it onto the landscape, just I'm doing on screen. Make sure to save your level to keep everything safe. So now we have our landscape here. Next I will drag out the PCG graph first and see what happens. As you can see, nothing happening here in the detail panels, so you can go to the PCG component section to check it out. We have all the nodes of the PCG graph here. Now I will break down them in detail for you. I use the spline to control the areas where I want things to spawn. In the actor selector settings, pay attention to actor section and set it to tag. Here I have assigned it a tag called Spline Forest. Now we need to create a blueprint that contains a spline. In the component section, add a spline here, just I'm doing on screen. You should use close spline so the PCG spawns inside the interior area. Like this, and then go to the class default. Search tag. Let's go back to PCG graph and copy the tag I created, Spline Forest. Make sure it matches exactly the tag we set it in the blueprint. Now you can see why my PCG can spawn inside this blueprint. It's worked by on spline. So that's wrap up the first step, how PCG spawns from a blueprint. In that blueprint, we can also add a PCG component. That's why you can just drop a single blueprint into the scene, so you have everything set up inside it. And that is for how to set up blueprint for PCG. Next, I will hide the unnecessary nodes, then enable them one by one and explain what each of them does and why they use. This is the get spline data node. Its purpose to spawn our PCG along the spline, just I mentioned earlier. Next is the spline sampler. It determines how the spline spawns, whether interior or exterior, and control the number of points that get spawned. When I added the interior simple spacing, you can see the point change. Low values result in more points being generated within the spline. Just I'm showing on screen. Okay, that's it. Next, we will move on to the projection nodes. This node lets us align the points onto the landscape surface. Let me give you an example. When I switch to scope mode, the points will move and adjust to follow the landscape terrain. In the projection target section below, use the get landscape data nodes and plug it into it. This will pull data from the landscape. That's what the two nodes are used for. Next is the transform point node. It lets you adjust the scale, transform, and offset of the points. I used this node as a mark to clear space along the spline for rows or water by removing points within the set array. Here I will give you a quick example to explain this node. I just need to enable the rest point node here. I will go into more detail about this later in the video. I'll drag out this spline router and see what happens. As you can see here, the black points are concentrated in the middle of the spline and gradually fade out toward the X to creating space. For the waters, this little node works similarly. It calculates how far cheese can spawn around the river. I will show you an example. First, you need to turn on the water plugin. I will add it to the level. That's the function of the distance node. The higher the value you set, the fewer points will appear near the river. Next, I do the different node, which is used to subtract one dataset from another, like removing all points that fall inside a spline area. First, we also have the get spline data nodes. I'm using set by task method, just gridded in the first part. You also need to make sure that the tag you set are exactly the same between the spline in the blueprint and in the PCG graph. Next is the spline symbol node is the same as first pass. Let me drag it out and show you an example. I will cut out an empty areas, removing all the points generated by outline forest and turning it into a clean mask. This allows us to place buildings or whatever we want based on our design intent. The bound modify nodes allow us to adjust the scale and position of the points, letting us make the mask wider and narrower compared to the spline. Okay, that's it. Union node used to combine multiple datasets into one. Here I also use a transform point node to add some random rotation. Finally, to fill this node change with your named root node, it helps us to organize and redirect data flow in the PCG graph, and you can see in my screen. Next, from the forest point, we split it into two parts, one for trees and plants and one for rocks. I will use a different node here to separate the rocks from the plants so they don't overlap with each other. We start with rocks point, and I have an attribute node here. It can help to add randomness to attribute like position, scale or density to make the result look more natural and less uniform. And density filter is used to control where points stay or get removed based on their density value. I'm using attribute noise again, continue from the density filter and transform points to make the rocks randomness. I repeat this process one more to make the rocks spawn more naturally. Here I'm using the bound modify node to expand the bounding area of the rocks, preventing trees and plants from overlapping into that space. Next is the transform point node. We can increase the randomness for the rocks by adjusting the rotation and scale. Next is the static mesh spawner. In the mesh and child section, I've added the rocks mesh here. I'm using 3 different types of rocks as an example, as you can see on my screen. In the end, we have a bound modify node here. This is the different node which help us separate the point between the rocks and plant. Next, the transform point and density filter nodes help us adjust the randomness of vegetation and spawn points, making our PCG look more natural. And attribute noise is also like this. Now we move on to a very important part, the tree spawning section. Let's start with the big trees. From the forest point, I'm using an attribute noise node to randomness where the big tree will spawn. You can adjust the noise means and mark values, just I'm doing on screen. The density filter here controls how many big trees are spawned. I'll show you later how to create a parameter so you can adjust it directly. This is the transform point, which allows us to directly adjust the scale, rotation, and offset of the cheese. Zone nodes are used to generate smaller points around our large cheese. First, we create points to generate the points, then transform to adjust them, and we use copy points to copy the large cheese onto those points. The nodes ensure we have smaller cheese around the big ones, making each cluster look more natural and realistic. We connect them to projection to sample data from the landscape, so the points are slapped onto the surface. Here I use the distance nodes to calculate how far the small cheese are from the big ones. Let's see how it looks. It looks interesting. Here I use the scale by density node to control the size of the cheese around the big cheese, as you can see on screen. I adjusting the scale min and scale max. You see it's very exciting. Then I use attribute noise and density filter to control randomness and the amount of the cheese. Next, let's move on to the medium cheese section below. We also have three nodes similar to the big cheese section: density filter, transform point, and static mesh point. They work in very similar ways to the previous step. The nodes allow us to spawn smaller cheese around the medium cheese. If it's not clear, you can go back to previous section. Here I use the distance node to generate spawn points closer to the river. I have a name reduced called watermarks, which I will explain more later. For now, it mainly helps separate the river area from the medium cheese. The density remap nodes adjust density values, letting us control how dense and sparse the distribution of point is. At the end, we have the static mesh point nodes, which contains a smaller cheese around my medium cheese. In the final part of the forest biome, we'll spawn the cheese stump and small bushes. Here, since the values are low, we take points from the forest point to spawn them, and we use more points compared to the previous two sections. They are the same nodes I used in the previous section, so I won't go into too much detail to avoid making the video too long. You can just follow along on screen. Next, we'll move on to the road path section. Here for the get spline node, we also set it using a tag. We will move on to the spline samplers. In the mode settings, we'll change it compared to the forest point and forest remove. We switch it to distance. This makes the point spawn along the spline instead of using interior like before. In the distance increment section, adjusting this value controls how many points are spawned along it. And don't forget to enable unbound so the spline affects the entire level. The create point grid and density filter nodes help us generate additional points along the spline. Here we also have nodes like transform points, projection, and their function is quite similar to the ones we used before. The path is a bit more special because I'm also spawning fallen cheese here. They have some additional functionalities, so let's continue and take a closer look. Next, we have the copy points and the mesh sample nodes. We make sure the two meshes are similar, so we can use the points generated from those meshes. I also use an attribute noise node to add randomness. Normal to density allows us to take points based on the surface normals of these objects. The density filter helps us to filter the points we want from the normal base density. At the end, we still have density filter, self-planning, transform points, and static mesh spawner, similar to what was done in previous sections. And that's all for road path. Let's move on to the lake part, the water river section. First, we also have the gas supply data nodes. In the details panel, we need to note that won't set it by tag anymore, but instead to by class. Thus I'm doing on screen. Remember enable water plugin on the plugin section. I will try adding a water body river. I have two Spline sample nodes here. One is used for spawning the route and other one below for the vegetation around the river, and in the mode set it to distance like a road path we did before. For the route, I use never instant to customize it rivers. You can see the whole progress on the screen. Once we have a level instance like this, the next step is to create a PCG data asset by right-clicking and selecting the Create PCG Asset from level, and set it up like this. In the static mesh spawner node, under the mesh selectors, switch it to PCG mesh selector by attributes and set name it mesh. In this section below, I'm using it to spawn plants around the river, but it's not too important. The loads are quite similar to what we done before, so I will just go through it quickly. In the nodes inside this surrounding roof, I will set it up specifically for everyone who wants to customize plants along both sides of the river. You can check it out here. Alright, next we will move on to the final part, PCG Paint Landscape. Here I will briefly summarize it. With your landscape layers to paint the plants that we've already set it up in advance. I will start with the gas supply data node, which works similarly to forest point we set up earlier. I similar to control the number of points along this supply. Then we use the projection node to slap those points onto the landscape. We need to pay attention to a very important node here, filter attribute elements. This is where we can extract data from the landscape layers. In the details panel, we should pay attention to the target attribute section. Here I've set it to a. Why did I set like this? Let's keep going and find out. Open the landscape mode tab. In the layer section, you see the layer name like auto materials A, B, C, D, etc. We need to make sure the names of the layers match target attributes so this node can correctly receive the data from them. The next part is just nodes like attribute noise, density filter, transform points, and static mesh spawner, which we use to spawn objects from the points we extract from those layers. As you can see here, when I paint layer A, the plants only spawn in that specific areas because we already set it up beforehand. I will do the same for layer B and C below, just like layer A, so you can try it in your own PCG setup. The operator lines are used to filter based on attribute values, so you can control exactly where points are kept or removed. And that's the end of the beginning introduction to PCG. In part 2, I'll show you how to create parameters so you can control everything more easily from the level. Okay, let's do it. The first thing I want to show you how to control the tree density in this PCG graph. Okay, let's start with the big trees. As you can see here, when I adjust the lower bound values, the number of the tree increases or decreases. Let's click on the PCG graph parameter tab. If you cannot see it, Go to the window menu and enable graph parameters and the parallel viewer piece. Click on parameter to create a new one. There is a type options and you can choose different types. But as you flash, so the values can smoothly increase or decrease. I'm naming it big cheese density. Yeah. In the density filter nodes, click the small drop-down arrows and a menu will appear. There are the attribute types we can collect too. In this case, I will use lower values. To collect it, just call the parameter we created earlier and plug it into the lower bound, like I'm doing on the screen. Let's go back to the level and test this. In the details panel, scroll down to the PCG sections, you see the PCG parameter there. You can adjust them to see how it works. As you can see here, when I increase or decrease the value, the number of the cheese also changes. This lets you quickly control everything without going back to the PCG graph and adjusting each node manually. Awesome. Now I will set it up for the medium cheese as well, so you can see the process on screen and check the result. Everyone can see here it's working quite well. Do the same for the cheese stem and bushes. Next, I will show you how to quickly swap meshes using parameters from the outside. I have 3 cheese meshes. I will turn them into parameters so we can swap them quickly. First, you need to open the content browser and go to structure and create a new structure. After opening that structure, I will add another variable to it. Just follow along on screen. It will have 2 variables, one image and the other weight. The weight is used to control the priority or distribution of the tree here. For the mesh variable, set it to static mesh, and for weight, set it to float. That's it. Let's go back to the PCG graph. Here I will create a new parameter. For the type, make sure to search for the name of the structure we created earlier. For the type, make sure to set it to an array so we can assign multiple access at once. Now let's add the default tree types to this parameter. Now we will bring a node called match and set attributes. Then call the bridges types parameter we created earlier and plug it into the match data input. Press A to view the attributes and check whether it's receiving all data correctly. Now we will plug it into the static mesh pointer. In the mesh selector, switch it to by attributes and set the attribute to mesh. That's it. Now let's go back to the level and try swapping the cheese to see how everything works. Okay, everything is working well. Now let's go back to the PCG graph. In this node, we have the match weight attributes. Set it to weight. As you can see here, when I increase the weight, certain cheese like the taller ones are priority and get spawned more frequently. That's the purpose of the weight. That's it for swapping cheese meshes. Now we will move on to the creating a parameter to control the scale of the cheese. Just like in previous steps, we will create a new parameter and give it a name as shown on screen. Next, we need to add a node called multiply. And set up like I'm doing on screen. In the detail panels, go to input source, set it to points, then enable scale. Now that we've set up the scale, let's go back out and test to see if it's working. It's working fine. As you can see here, when I adjust the seed in the attribute noise node, it changed the randomness of the points. Now I will show you how to create a parameter to control that randomness. Alright, let's get started. First, create a new parameter and set its type to integer. Now I will plug this parameter into the attribute noise node. Just follow along on screen as I do it. Okay, that's it for the seed. So in today's video, we will learn how to create parameter to tweak things directly in the level in just a few simple steps. You can adjust the setting right in the level without having to go into the PCG graph. I have also uploaded this project on Gumroad. You can support me by grabbing it there, like buying me a coffee. Okay, thank you. In the next part, I'm planning to bring all the parameters we've created in the PCG graph into a single blueprint so we can control everything from there. Thank you all so much for watching. I really appreciate it. Bye bye.